A huge asteroid hitting the ocean would be a disaster that would have a big effect on the places around it. First, the force of the impact would make a huge tidal wave, also called a tsunami, that would move across huge areas of the ocean and could do a lot of damage to cities and towns along the coast. A lot of water would also be released and moved around by the impact, which would lead to more damaging waves and floods. There is also a good chance that the asteroid hitting the water would cause an explosion. The heat and pressure from the impact would be very bad for aquatic life. Debris and ocean matter would be thrown into the air by the blast, which could pollute the water around it and do long-term damage to the environment. Radioactive material could also be in the debris, which would make the damage to the environment and any living things that are there even worse. A lot of heat and steam would also be released into the air when the asteroid hit. These gases could do a lot of damage to the environment. For example, they could cause global cooling by forming a thick layer around the Earth that would block sunshine and cool things down. Lastly, the meteor impact would probably do a lot of damage to the economies of any nearby businesses, like fishing or tourism based on water. This could have more long-term effects. The effects of a huge meteor hitting the ocean would be very bad, so we need to be ready with backup plans for these kinds of scenarios. To destroy Earth, what size of an asteroid would have to hit it? A lot of things go into figuring out how big an asteroid would have to be to destroy Earth. How big of an asteroid would have to be to destroy Earth depends on a lot of different things. Let's break it into several important parts. We should start by thinking about how much energy the blow gives off. If you know how fast, how heavy, and what angle the rock hit, you can figure out how much energy it released. An asteroid's mass is usually directly related to how much energy it releases when it hits something. This means that the destructive force of the strike is greater when the asteroid is bigger. After that, we need to think about what the consequences will feel like. A collision with an asteroid can send shockwaves, firestorms, and tsunamis through the Earth. It would depend on how bad these impacts are to know what size meteor would be needed to destroy Earth. If an asteroid hits and starts a big blaze, for example, it might kill all the living things on Earth, but it might not do that. Considering where the effect will happen is another important thing to do. Land would be more damaged by an asteroid than the seas. If a strike happened in an area with few people, it would cause less damage than if it happened in an area with many people. Taking all of these things into account, scientists think that it would take an asteroid with a diameter of about 10 to 15 kilometers to destroy the Earth totally. This asteroid would start a huge firestorm, send shockwaves and shocks across the world, and maybe even turn the oceans into steam. Of course, there is a very small chance that such an asteroid will hit Earth, since objects that big rarely do. How big of an asteroid would it have to be to destroy Earth depends on many things, such as its mass, speed, angle of impact, site of impact, and the damage it would do. Scientists think that it would take an asteroid with a width of about 10 to 15 kilometers to destroy the Earth, but it's not likely that this will happen. What size was the asteroid that killed the dinosaurs? It is thought that the asteroid that wiped out most of the dinosaurs 66 million years ago was about 10 to 15 kilometers, 6 to 9 miles, across. It was most likely a carbonaceous chondrite that has a lot of carbon and water in it. It was moving at about 40,000 miles per hour when it hit Earth's atmosphere, sending out a huge shockwave that destroyed a lot of the planet. The rock would have given off a huge amount of energy when it hit, about the same as 10 billion Hiroshima bombs or 100 trillion tons of TNT. It was this energy that turned the asteroid into a cloud, which formed the Chicxulub crater, a circle about 180 kilometers, 112 miles, wide that lies below Mexico's Yucatan Peninsula. The impact was so hot that it started wildfires and made huge clouds of dust and debris that covered the sun and cooled the whole world for a while. Many plant and animal species died out because of this, including the non-avian dinosaurs, which were the most common species on Earth at the time. About 75% of all species on Earth at the time are thought to have died out because of the asteroid. The asteroid that killed the dinosaurs was very big and had devastating impacts on Earth, changing its environment and wiping out many species. Is it possible to prevent an asteroid from striking Earth? Yes, it is technically possible to keep an asteroid from hitting Earth. The way to do that, on the other hand, is complicated and hard. One common way to keep an asteroid from hitting Earth is to push it away from it. To do this, the asteroid's path must be changed just enough so that it doesn't hit Earth. A gravitational tractor is the most common way to steer comets away from Earth. In this case, a spacecraft would be flown close to the asteroid, and its gravity would be used to pull it off track. For NASA's Planetary Defense Coordination Office, PDCO, the Johns Hopkins Applied Physics Laboratory, APL, built and managed the Double Asteroid Redirection Test, DART. It was the first demonstration of planetary defense technology in the world, and it proved one way of deflecting asteroids using a kinetic impactor spacecraft. Launched on November 24, 2022, by a SpaceX Falcon 9 from Space Launch Complex 4 East at Vandenberg Space Force Base in California, DART went for more than 10 months before it purposely hit the asteroid Moonlet Dimorphos, a small celestial object only 530 feet, 160 meters, across. The asteroid Dimorphos is part of the Didymos binary asteroid system and orbits the bigger Didymos, which is 2,560 foot, 780 meter, in diameter. After or before DART's kinetic impact test, neither Didymos nor Dimorphos could hit Earth. The mission's one-way trip proved that NASA can safely guide a spacecraft to hit an asteroid on purpose in order to change its orbital path. The only tool DART had was the Didymos Reconnaissance and Asteroid Camera for optical navigation, DRACO. It worked with a complex guidance, navigation, and control system that used small-body maneuvering autonomous real-time navigation, SmartNav, algorithms to help find and separate the two asteroids, target the smaller one, and guide the box-shaped spacecraft that weighed 1,260 pounds, 570 kilograms, through the last 56,000 miles. The spacecraft's last DRACO pictures, taken just seconds before impact, showed the surface of Dimorphos in great detail. The Italian Space Agency gave DART's CubeSat companion, Lycia Cube, 15 days before impact. It was launched from the spacecraft to take pictures of the impact and the cloud of matter that was thrown out by the asteroid. To change the path of the asteroid, explosives can also be used. However, larger asteroids may require a more advanced method, so this method is only good for smaller ones. People have also suggested destroying the asteroid completely as a way to stop it from hitting Earth. Some people think that using a nuclear device is the best way to do this. Larger asteroids might need a series of nuclear blasts, though, so this method only works for small ones. There is also some disagreement about using nuclear weapons to destroy comets because of the possible effects on society and the environment. Although it is technically possible to keep an asteroid from hitting Earth, it is not likely that this will happen. A huge group of scientists and astronomers are working non-stop to find and track asteroids that could be dangerous, and tools used to find them are always getting better. A number of tracking and early warning systems have been made possible by these efforts. They are meant to let the officials know if an asteroid is heading straight for Earth. It is possible to keep an asteroid from hitting Earth, but it is hard and complicated to do so. But we can keep lowering the danger that asteroids pose by working on new ways to find them and deflect or kill them. Could people survive an asteroid impact? The aftermath of an asteroid hitting Earth can be very bad for life on Earth. How big of an impact and how much damage it can do depend on how fast and how big the asteroid is. But whether or not people can survive an asteroid relies on many things, such as the size and location of the impact, their ability to predict and plan for such an event, and how strong their society is. If we imagine that a big asteroid hits Earth, the results would be horrifying. How bad the crash is will depend on how big the asteroid is. A big asteroid hitting Earth could cause a world disaster that wipes out many species, including humans. There would be a huge blast, and a lot of dust and other things would be sent into the air by the impact. A global cooling effect that could last for years would happen because the sky would get darker. The cooling could cause many crops to fail and cause hunger, which would kill many people from not having enough food. But people have lived through other terrible events like earthquakes and volcanic eruptions that did a lot of damage to the world. We now have some technology that lets us predict and get ready for natural disasters. Over the years, it has become easier to find and keep an eye on possible asteroid strikes. We can now find and keep an eye on potential threats. For example, if we find an asteroid that is likely to hit Earth, we can get ready for it. Likewise, there are several ways to lessen the damage that an asteroid might cause. So that Earth doesn't get hit, some of these plans involve steering the meteor away from it. It's not impossible for people to escape an asteroid's impact, but it would be very bad and could wipe out whole populations. Better predicting and planning for natural disasters, as well as creating technology to lessen their effects, are the most important things we can do. Our chances of survival in the event of an asteroid impact can be improved by making the right plans. If an asteroid hit, how big would the tsunami be? The magnitude of a tsunami produced by an asteroid impact would depend on a number of variables, including the asteroid's size, speed, angle of impact, and depth of the water where it made contact. The impact an asteroid would have on the ocean and its surroundings would be greater the larger it was. The displacement of a significant amount of water during impact by asteroids with a diameter more than 1 kilometer has been demonstrated to result in enormous tsunamis. In fact, a meteor that was barely 20 meters across in 2013 triggered a tsunami in the Chelyabinsk region of Russia, impacting more than 1,000 people. The size of the tsunami is significantly influenced by the speed and angle of impact. The size of the wave would be greater if the asteroid hit the ocean at a shallow angle and fast speed, as opposed to a steeper angle and slower speed. This is so that a bigger surface area of water would be displaced by the asteroid and result in a larger wave in the event of a shallow angle impact. The magnitude of the tsunami would also be greatly influenced by the depth of the ocean at the collision site. In comparison to the open ocean, where the depth of the ocean floor is often greater, the asteroid would produce a stronger wave if it struck a shallow coastline. Depending on the specifics of the hit, there would be a wide range in the size of the tsunami produced by an asteroid impact. It is safe to suppose that a major asteroid impact would result in a significant tsunami, which would wreak great destruction and a great deal of casualties. In case of such a disastrous catastrophe, it is crucial that we be ready and have an evacuation plan in place. If an asteroid crashes into the ocean, will it trigger a tsunami? It can be difficult to determine if an asteroid would trigger a tsunami if it crashed into the water. The degree of the potential harm will be greatly influenced by the asteroid's size and weight. A tsunami's chances will be greatly influenced by the asteroid's speed and angle of impact, as well as the depth of the ocean near the impact site. Understanding how tsunamis are created is crucial before considering the potential repercussions of an asteroid impact on water. Tsunamis are a series of massive waves that occur when there is a rapid, large-scale movement of water, such as that caused by an earthquake or a landslide. When these alterations take place in the ocean, the water is displaced, which causes it to flow quickly and produce waves. If an asteroid were to crash into the water, the powerful force it would produce would cause a great lot of water to be suddenly moved, which would cause waves. The size of the asteroid, its speed, angle, and size, as well as the depth of the sea at the impact site, would be the main determinants of the tsunami's size. The waves caused by an asteroid may do extensive damage in coastal areas if it were big and fell into deep ocean at a fast speed. The time it would take for the waves to reach the coastline may be significantly quicker, and they would likely be far larger than those brought on by a typical earthquake-induced tsunami. But it's important to remember that not every asteroid collision would cause a tsunami. There might not be much displacement caused by the asteroid, and the waves that were created would be much smaller if it fell into shallow waters or was small enough. While it is hard to know with confidence what would happen if an asteroid impacts the water, we can draw the conclusion that it is feasible for an asteroid to trigger a tsunami if it does so. The intensity and scope of the potentially devastating impacts of an asteroid-induced tsunami are largely dependent on the size, weight, speed, and angle of impact, as well as the depth of the sea. What kind of harm could a 100-foot asteroid cause? A 100-foot asteroid's potential destructive power is dependent on a number of variables. The asteroid's speed is a key consideration first and foremost. The impact would most certainly cause a small explosion, and leave a sizable crater at the point of contact if the asteroid was moving at a modest speed, say 10 to 15 miles per second. On the other hand, if the asteroid was moving quickly, say 25 to 30 miles per second, it could wreak serious damage upon contact and could trigger disastrous events. Likewise, it depends on where the asteroid collides. If the asteroid collides with the surface of the Earth in a remote location, it might not cause much harm. But if the asteroid strikes a heavily populated city, the results might be disastrous. The impact might result in extensive damage, including loss of life, property loss, and infrastructure loss. The makeup of the asteroid may also affect how much damage is caused. The asteroid may be less harmful if it is made of a solid material that resembles rock as opposed to metal or a mixture of rock and metal. This is due to the fact that an asteroid that resembled a solid rock would fragment more readily as it hit the Earth's atmosphere, producing tiny fragments that would cause less harm than a single solid mass. Several variables, including the asteroid's speed, location, and composition, can affect how much damage a 100-foot asteroid can cause. By identifying any incoming asteroids and devising plans to lessen their effects, it is essential to avoid such possibilities. By doing that, we may guard the world and its inhabitants and contribute to the prevention of potentially catastrophic occurrences. How much time did it take the Earth to recover from an asteroid impact? The asteroid impact, known as the Chicxulub impact, which occurred around 6 to 6 million years ago, left enormous destruction and devastation in its wake. Including the well-known dinosaurs, 75% of all species on Earth perished as a result of the hit. One of the most important mass extinction events in Earth's history is this one, according to experts. As soon as the asteroid and Earth collided, the recovery procedures started. Global cooling, acid rain, and wildfires were caused by the impact, which released a tremendous amount of energy and threw a large amount of material into the sky. It took thousands of years for the environment to recover from the initial hit and its after effects. A considerable drop in the world's temperature was brought on by the asteroid's instant impact and persisted for several years. The majority of plant species died as a result, which in turn triggered a series of ecological changes. All of these changes together caused the extinction of dinosaurs and other huge land creatures. The Earth's ecosystem experienced an extended and gradual phase of recovery after the impact. Biodiversity levels reached before the asteroid impact did not occur for millions of years. It took a long time for new species to evolve and for existing species to adapt to changing environmental conditions. It took millions of years for various plant species to repopulate the world, and the recovery of plant life was essential for the revival of animal life. Another important factor in the Earth's long-term recovery was the ozone layer's restoration, which was harmed by the asteroid impact. The time it took for the ozone layer to fully recover was about 5 million years. After the Chicxulub impact, Earth's recovery took a long time and was sluggish. The recovery of the Earth's ecology took millions of years, and biodiversity was only re-established through the emergence of new species. The asteroid's collision demonstrates the impermanence of life on Earth and serves as a warning that we must be careful in safeguarding the environment. What was the mph speed of the fastest asteroid? An asteroid's speed can change significantly depending on its size, shape, and separation from the Sun. The fastest asteroid yet observed, however, is 162082 1998 HL1, which is believed to have a top speed of about 33,000 miles per hour, 53,000 kilometers per hour, based on the data at hand. This asteroid falls into the potentially dangerous category because it is an Apollo asteroid, which implies that its orbit frequently crosses paths with the orbit of the Earth. It was found for the first time in April 1998 and has a diameter of roughly 2.7 kilometers. 1998 HL1 came within 1.2 million miles, 1.9 million kilometers of Earth in 2006 during its closest approach. This is equivalent to 5 times the distance between the Earth and the Moon, to put it into perspective. Even while it might seem like a lot, the distance is still close enough to qualify as a potentially dangerous asteroid. Because of their highly elliptical orbits, which lead them to speed up as they approach the Sun and slow down as they recede. Asteroid like 1998 HL1 travels at a fast speed. Although this asteroid does not now constitute a threat to Earth, it is important to keep track of its orbit and speed in order to determine whether or not it may one day have an impact on our planet. As Neil deGrasse Tyson says, asteroids have us in our sight. The dinosaurs didn't have a space program, so they're not here to talk about this problem. We are, and we have the power to do something about it. I don't want to be the embarrassment of the galaxy to have had the power to deflect an asteroid and then not, and end up going extinct. You can suggest topics you want to see next in the comments section below. Please subscribe to Weather Collapse if you want to know more and be updated on the latest news about natural calamities or disasters happening all over the world, and don't forget to like today's video. We'll see you in the next video. Thanks for watching.